Hi, and welcome to the second video of this Urban Analytics channel. My name is Ilgi. I'm an urban studies researcher in the field of urban analytics. First, I'm going to describe how the structure of the videos moving forward in this channel are going to be. It's going to be 5 minutes introduction into a subject, and then we're going to have 15 minutes or more of urban analysis tutorial, depending on how complex the subject is. It can be up to 30 minutes, but that's how videos moving forward are going to be. Before we get into today's video, I want to take a few minutes to explain what I mean when I say urban analytics, how I personally look at cities through this lens. So, urban analytics doesn't come from one discipline. Urban analytics come from many fields like urban planning, geography, data science, computer science, economics, sociology, transportation, design, environmental studies, public policy, and probably there are many that I forget, but there are many fields related to urban analytics that make urban analytics. So that's why I think there's not one correct method or one perfect model for learning urban analytics. And in different programs, for example, you will see different approaches. In my urban data science course that I took at NYU, we moved from basic statistics all the way to the more advanced statistical methods and machine learning methods. That's, of course, one path into the field, and that's a very valid way of learning urban analytics. I want to take an urbanist perspective and I want to flip these things around a little bit in this channel. When I'm sharing with you, I want to start with what cities actually are and then talk about how we can analyze them. So, because cities are complicated, they're like, they're not really complicated, they're complex. They're living, they're changing, they're like layered environments. And the way we study them should also reflect that. So, the way I introduce urban analytics is through three connected ideas: processes, people, and place. And those three things aren't really separate things, they feed into each other. But the structure of seeing them separately, knowing that they are interrelated things, helps us think clearly. So, first, I'm going to talk about processes, and we're going to start these series with processes as well. That means that cities are constantly moving and changing. For example, people are traveling, information is spreading, businesses are opening or closing, or markets shift, or neighborhoods evolve. There's a change. And this is a network approach. So when we look at flows and interactions, there are not like fixed shapes on a map. They're constantly evolving. If you're really interested in this idea and having to build this perspective, I recommend this book, The New Science of Cities by Michael Beatty. The second and the third chapter, also please read the first chapter if you get your hands on this book. It explains how cities behave like complex systems when it's driven by movement and communication and flows. And I think it's a good starting point if you want to understand cities as dynamic systems. So second, we're going to go and say cities are about people. Cities hold people in, right? They're social environments. People choose where to live, for example, where to work, how to move around, who to connect with. And these decisions, they shape how the city is made. So, for example, in this layer, we will look at the behavior, we will look at community patterns, we will look at equity, segregation, access, and basically how real human lives unfold in space. And it's good to know here that urban analytics isn't just about numbers, it's also about understanding lived experience. For example, who gains or loses from the way cities function. So, we're gonna look deeper into equity. So, third, when we look at space, we think about physical city, right? Like streets, buildings, parks, transportation networks, infrastructure, density, or land use patterns. And this is exactly the part we usually imagine when we think about the city. It's the shape of the environment and it influences everything else. How people move through configurational networks, for example, is one of my subjects. Who lives there, and how neighborhoods are made or feel or function. So those are the three lenses that I'm going to use in this series: process, people, place, and their interrelations. And what I think about urban analytics is simply the practice of understanding those systems and understanding those systems as interrelational and as a whole, using data, using theory and observation so that we can make better decisions and build better cities. So, with that foundation in mind, now we're going to talk about today's subject, which will be the first attempt to understand processes in cities. We're starting with the first part, more about exploring how cities behave through real data by looking at a map of 311 complaints. It's a service request, really, and we're gonna use NYC dataset about 311. It's an urban diary, residents recording what's working and what's not for them. Let's jump into it. Now, first of all, we go to NYC Open Data and we search for 311. Now, this is a very big data set, so we have to filter the date. So we're gonna choose only 2025 records. And we're gonna apply this, and then we're gonna export as CSV. We're gonna download this into our computer. Now, as you remember from last time, we have an urban analytics dataset. We are opening a new file in there called 311 data. We're also taking the dataset that we've downloaded into our urban analytics folder here. We are going to use the copy path function to use it later on our Jupyter notebook. So first of all, I'm importing pandas, geopandas, and also matplotlib. So importing the libraries should always be the first thing that we are doing when we open a new notebook. So, and then I'm defining our dataset called df. I use pd read csv and I'm pasting the name of the file and pressing enter, shift enter to be honest, to run the code. And then it's taking some time because the dataset is a little bigger than usual, and I'm using head to see the first 5 rows of the dataset. So we have lots rows in this file. Like we can use shape to know how many. Then after that, we are using dtypes to know the data type for each column. So I am looking at created date and closed date. An easy way to check the dates is looking at the create day and make it PD to date time using PD to date time.
we are transforming the data from object to datetime data. So once we have done that, we execute it, and then the data, the column is gonna appear as datetime. Once we did that, we are going to just copy and find the maximum and the minimum date. So we're gonna have min date using min function and max date using max function. And we're gonna print those two to see if the dates that we've collected are indeed the dates we want. So let's execute that, and we see both dates starting from beginning of 2025, so we're good. Now we're gonna look at complaint types. So when we are doing that, actually we're gonna use the exact same words as is written on the columns. So we're gonna use the exact capitalization. We have lots of complaint types actually. We're gonna choose one area that might be important for us. So you can choose any, really. We can to be able to understand which is more important or which comes up like more frequently, we can look at value counts, and we can say head 10 to understand which ones are the most frequent ones. So I'm looking at water system and street condition, and I'm going to choose water system. So I'm doing another dataset called water DF, and I'm going to use a lock this time to use a certain complaint type. So if you enter this code, it will only choose the water system complaints, and it will reduce the whole dataset to only water system complaint types. So we're gonna see the head of this just to be able to see if we're on the right path, and we are only seeing water system complaint types here. So next we are going to look at the descriptors. So because within water system we have different types of descriptor of what the water problem is. So like dirty water or hydrant problems, leaks, and things like that. So we're going to look at the top 10 water system problems. For that, we're going to use again the descriptor. We're going to use the value counts, and then we're going to say head 10. When we execute that, we will see the top 10 water system problems. And we can choose one that's interesting for us for later analysis. But first, what I'm intending to do is to make a plot of these main water problems, the top 10 water problems. For that, we're going to use matplotlib, and we're going to use plt figure, and we're going to enter the figure size, and then we're going to plot, the kind is bar, we're going to make a bar plot, and we want to have a title on the top as well. I'm going to say top 10 311 water system complaints. Then the next thing that I'm going to do is Actually, I want to change that and say descriptors like it's written on the dataset, and then I am working on the labels. So the X label is going to be the descriptor, and the Y label is going to be the count. So after putting all those information, we are going to plot using PLT. Tight layout, I'm using this just to so that it adjusts spacing and it's looking beautiful. I made a mistake, I believe, so I fixed that, and then we have a very squished bar plot, right? So we need to change the figure size to make it more even. So I change it to 10 by 10 and it becomes much more readable. So we have all of the descriptors and the counts on a bar plot. So that's the first thing we did. Then what are we doing? We can only concentrate on one type of descriptor, which is dirty water this time. We are using the same structure with lock. So we are only choosing and filtering out other descriptors, just keeping the dirty water by using the same log structure. Once we have done that, we have only the dirty water that's in our dirty water data set. And then it's time to import Folium to make an interactive map on where the dirty water is more concentrated in New York City. We're gonna try to visualize that. So first of all, I am importing a plugin that's called Heat Map because we're gonna use Heat Map to visualize where the dirty water problems appear the most. So we're gonna first drop all the rows that don't have any latitude and longitude, so they don't have a location, which will be problematic for visualizing them. We don't want that, so we're gonna drop the ones that don't have latitudes or longitudes. There is a problem because I didn't put the capitalization right, so I am changing to capital L for both latitude and longitude, and now I have the right data set to work on. So we're gonna do the heat map last. We're gonna name it heat data, and what we are gonna do, we're gonna make a list and we're gonna use a zip of the dirty water DF that we have, and we're gonna use only the latitudes and longitudes. So the zip function regroups every latitude and longitude as a pair, and the list function lists them for us to make visualization easier. So once we have done that, we execute this, and then we are going to create a M for our Folium map. And it's gonna be our the location will be New York City center locations. Of course, we are copying that once we have found it. And once we have done that, we're gonna also add zoom start to start at 11, and then we're gonna execute that. For the heat map, we're gonna use the heat data, the data set that we have made by regrouping the latitudes and longitudes of all the complaints for dirty water. We're gonna make the radius 15, blur 10, and maximum zoom 13, and add to M. And then we are writing just M and running it on a different cell. And we are left with the heat map of dirty water complaints, which is all around the 5 boroughs of New York City. We can see some concentrations here and there, so I'm going to zoom at different areas where the water complaints are a little bit more concentrated than others. And there is place in higher Manhattan as well. I think there is one very problematic one over there, and we can see and map all the water complaints.
So that's it for this week. I hope you enjoyed, and we are looking into bike trips next week. See you soon.